Hello, this is Aljets, Biweekly for 2 weeks of October 27th. So, some research that I've been doing. The OITP meeting was the big event, I feel like. So I went to that, took notes on that. Think I kind of have a solid understanding of what I'm doing. I'm kind of leaning towards the, calculation simulation side of the operation. Um, and I got some background on OITPs. Um, so labeled this diagram. I put it into the thing, but or the OneDrive, but I put it in here again. My guess would be that the ones in the red are the most important, are the ones that we should look at, because the green ones seem to be like mostly Alzheimer's drugs, and the red ones seem to be mostly substrates. And so the drugs that are included in that, in my mind, are more noteworthy than the green ones, which are just mostly Alzheimer's drugs. But could be wrong. Not really sure. That's just my guess, my estimate. Did more PyMol tutorials. Did, probably 4 to 6 of them. I got comfortable using it, like as I got down the line of the molecular memory ladies tutorials. Felt better about it. I was hammering through it. Obviously it was, still a little tough though. I gotta keep the muscle memory up on the specific uh functions and stuff. I did get confused on the substrates project, but now I'm going through it. I made a folder that's all the references, and I saved all the references as PDFs. So I'm gonna go through all those very quickly. Hopefully, that's why I put it in the references. And find some mutants, and then change the Excel sheet. And then I also was playing around in Python after I got like some work done with like I just looked up like big data sets, and then they have basically this, they do like flyovers and like with magnetic sensors or whatever. And I was trying to figure out how to interpret that by stealing someone else's code that I found online and getting it to run. Got it to run, no output. I was really confused. So I quit. But it was another couple hours of Python experience. So I took it as a positive. More OITP substrates, mutants project on the sheet. Got to get that done, and probably something else within the next 2 weeks. I mean, I won't. I would be surprised if that takes me that long. The sheet. I was passing as I was searching through all the reference papers for the substrates. I found one that was on the blood-brain barrier, and I was a little, I guess, surprised, like weirded out, because it seemed like kind of similar to the work that we're doing, except it was from like 2000. So I clicked around to some similar stuff. Kind of found out that we've known about the blood-brain barrier and the OITPs there for a couple of years. But still, definitely, it seems like they're more worried about how it works and not how to get it to work for different drugs. So I was like, all right, I have a better understanding now. So more stuff, blood-brain barrier, impermeable, tight junctions. Um, I learned about sonic hedgehog protein, a little odd. Um, and then, some passive diffusion, but it seems like in general. blood-brain barrier, fairly stiff barrier, different OATPs. The paper that I was reading said 2B1 and 1A2 appear to be the most relevant drug transporters. I wasn't really sure why. It was a really dense paper. It was a lot of words and biology and stuff, biochemistry. Um, but I guess that's something to think about as I sift through the stuff. So some questions I have and some comments. I went to the University of Michigan Natural Science Museum, and in one of their like exhibits or like on the walls, they had a bunch of 3D printed like things from Primal. Like this is a sodium potassium pump. Um, and I was just like, I do this. Like I was kind of surprised. It was like a 400s level class, and they were like 3D printing this stuff. So I thought, oh, I didn't know I could 3D print stuff from Primal. And oh, I'm doing this cool thing that seems pretty advanced for even Michigan. So I guess would it make sense to 3D print stuff? I'm assuming not because like, like I don't think it would work to test whether um, a substrate would go through an OTP because there's like motion in real life and stuff. But I thought about it. And then just in general, for the blood-brain barrier, because it reaches the central nervous system, like if like a medicine could reach that, like not medicines could also reach through that theoretically, which could have more effects on, you know, recreational drugs or whatever. So I was just, that was something that I thought of, figured it'd be something I could put here. And then the machine learning in this project, we're like using it as a tool, correct? And not like we're not plugging in a bunch of data to a machine learning thing and just publishing whatever it spits out. We're like, I don't know. Because I think initially when I heard like machine learning and like protein engineering and stuff, I would kind of think that it would be used to find conclusions, but I don't really think it is anymore. So maybe a little clarification would be nice. But I believe that's all I have. Um, yeah, have a good fall break. See ya probably on Friday again.